Well, hi there, boys and girls. Today we're going to start our basic differentiation rules, and we're going to learn a lot more about derivatives this chapter. So let's just get started with our basic power rule. Our power rule works for any function that is x to some power n, where n has to be a number. And this derivative will be n times x to the n minus 1. That is your power rule. You saw that last year in pre-cal. So we're going to practice that. So let's do an example. If f of x is equal to x cubed, then f prime of x would equal, the power rule says we bring the exponent down in front, and then we subtract 1 off of that exponent. So the derivative, or f prime of x, is going to be 3x squared. If we have a root, you need to rewrite this as a power. Now, square root means the 1/2 power. So the square root of x can be written as x to the 1/2. The derivative of this will be 1/2 x to the negative 1/2, which can be rewritten as 1 over 2 x to the 1/2. That's an exponent rule you guys learned in Algebra 1. You saw it again in Algebra 2, and you also saw it again in pre-cal. If you have a negative exponent, you can just bring it down to the bottom. You could also rewrite this, if you want to, as 1 over 2 square roots of x. And in my opinion, this is worth memorizing. The derivative of the square root of x is 1 over 2 square roots of x. Let's take a look at another one that we need to rewrite, 1 over t to the 4th. I would rewrite that as t to the negative 4, so that it looks like x to the n. And then we're just going to use our little power rule, so our derivative is negative 4 t to the negative 5th. Remember, you subtract 1 from the exponent. Negative 4 minus 1 is negative 5, and then you could rewrite that as negative 4 over t to the 5th. That would be your derivative. What about 5? 5 doesn't have an x on it. Well, I guess we could tack an x on if we want, but we'd have to be x to the 0, because x to the 0 is 1. So you could write this as 5x to the 0. Anything to the 0 power is 1, so that's still 5. And if you did your derivative rule, you would bring the 0 down, and 0 times 5 would knock it out and make the whole thing 0. And that's something, let's go ahead and write down here. If c is a constant, like 5 is a constant number, the derivative of any constant is 0. This should make sense to you geometrically because derivative means slope. Here's a graph of the line y equals 5. That's y equals 5. What is the slope of that line? What's the slope of any horizontal line? It's 0. All right. Then here we've got the derivative of 5x cubed. What do we do if there's already a number here? Well, we still can use our power rule. We're just going to keep the 5 there. We're going to bring the 3 down and multiply times the coefficient of the x cubed, and then subtract 1 off. So that's just 15x squared. Sums and differences. If you have the derivative of a sum, it is the derivative of the first function plus the derivative of the second function. And if you have the derivative of a difference, it's the derivative of the first function minus the derivative of the second function. It's sort of common sense. We just roll on through the plus and minus signs. So let's take a look at this next example that has 4 things separated by pluses and minus signs. I'm just going to take the derivative of each term, term by term. So the derivative of 4x cubed is 12x squared. You bring the 3 down in front and multiply it. Don't forget to subtract 1 off the exponent. And then minus the derivative of 5x squared is 10x to the first. I'm not going to put a 1 there. Now the derivative of 7x, this is 7x to the first. I'm going to write this out over here, 7x to the first. Once you bring the 1 down, the derivative becomes 7x to the 0. So the 1 came down in front of the 7 and just multiplied it, and x to the 0 is just 1. So that's just 7. And then the derivative of a constant is 0. Now the example you're going to run into is if you're dividing by a monomial. Monomial means one thing on the bottom. If that happens, you need to separate this into, we're going to do some algebra before we ever do a derivative. So 5x to the 5th over x minus 3x to the 4th over x plus 4 over x. So we're going to separate it first and simplify. 5x to the 5th divided by x, one of those x's is going to cancel, so that's going to leave you with 5x to the 4th. Then one of these x's cancel in the second term, and we get minus 3x cubed. And I'm going to write this last term as 4x to the negative 1, so that I can have everything, so I can use the power rule. So my derivative is going to be 20x to the 3rd minus 9x squared minus 4x to the negative 2, which you could rewrite if you wanted to, but I'm not going to. We are not forced to simplify in calculus, so I'm going to leave it like that just so that you can. Now let's answer a question you'll have to do on your homework that says determine the points at which the given function has a horizontal tangent line. Points have to be in x comma y form, so when you answer it, you can't just leave it in x equals. Horizontal tangent line means that the slope is equal to 0. That means that our derivative has to be equal to 0. So I'm going to take the derivative, f prime of x, which is 3x squared minus 12, and I'm going to set that equal to 0. So I guess I'm going to add 12 to both sides, and then I'll divide by 3, and then I'll take the square root, and I get two places, plus and minus 2, where we have a horizontal tangent line. Now, I told you earlier that the points have to be x comma y. These are my x points. I actually have two solutions here, 2 comma something and negative 2 comma something. How do we get the y value for any value for x? I'm sorry, the matching y value for any x value. You always use the original function, so you can plug in 2 in for x, and you're going to get negative 16. And then if you plug negative 2 in for x, you get a positive 16. So these are the two places where the tangent line is horizontal. Alright, you need to know two things. The derivative of sine is cosine. Just a statement. We'll look at that geometrically later. There's a reason for that. And the derivative of cosine is negative sine. So let's see if we can do another example. Now I'm mixing x's and cosine. So what is the derivative of 6x squared? That's easy. That's 12x. Now the derivative of 5 cosine x, since we're going to keep the 5 there, the derivative of cosine is negative sine. This is going to be minus 5 sine of x. Minus 5 sine of x. It turned negative because the derivative of cosine was negative and the 5 just stayed there. We're going to review real quick what average rate of change is. Average rate of change is our secant line slope, and that is going to be, for this example, f of 5 minus f of 1 all over 5 minus 1. And I did this earlier, and that worked out to be, well, I didn't do it earlier in the video, I did it earlier on my calculator. That worked out to be 54 minus 2 over 5 minus 1, which happens to be 13. So then I'm using that function right there. Now the instantaneous rate of change means you have to take the derivative. You must take the derivative, and then we're going to plug in 3. So in other words, I want f prime of 3. And we're going to use the shortcut now instead of that definition of the derivative. So I'm going to find f prime of x first, which is going to equal 3x squared minus 6x. So f prime at 3 would be plug 3 in for these x's. So that's 3 times 9 minus 6 times 3, which is 27 minus 18, which should be 9. So the average slope was 13, but the specific instantaneous slope was 9 at the x value of 3. Alright, so we're going to do last example here. Find k so that the function x squared plus kx will be tangent to the line y equals 2x minus 9. Two things about a tangent line. They must share a point, so they must intersect, and they also must have the same slope. So there's two equations I'm going to write. First of all, x squared plus kx has to equal 2x minus 9. That is the fact, that would be their intersection. Also, we have to have that their slopes are the same. Now the slope for x squared plus kx comes from its derivative. So f prime of x would equal 2x plus k. Now the slope for the line y equals 2x minus 9, you should know that its slope is just 2. mx plus b, the slope is just 2. So their slopes have to be the same and their points have to be the same. So this is the algebra that I have to do. X squared plus kx has to equal 2x minus 9, and also 2x plus k has to equal 2. There's two things that must be true. So what I'm going to do is, I guess, use a little substitution here, and I'm going to have that k equals 2 minus 2x, and I will substitute that value up in for k here so I can figure out my x values. So I'm going to scoot on down here. So x squared plus 2 minus 2x times x equals 2x minus 9. So x squared plus 2x minus 2x squared has to equal 2x minus 9. So negative x squared has to equal negative 9. These two x's canceled from either side. So x equals plus or minus 3. We actually have two values for k here. So I'm going to use this equation right here that relates x and k so that I can find my k. So, well, actually, it'd be easier to use this one, wouldn't it? K equals 2 minus 2x. So k is going to equal 2 minus 2 times 3, and k is going to equal 2 minus 2 times negative 3, which is going to equal, I guess that's negative 4, and this is 8. So there are two solutions for k. All right, well, that's it for differentiation rules and some practice on some questions, and I will see you guys tomorrow.